California Bearing Ratio, CBR. It is the method for evaluating the stability of soil subgrade and other flexible pavement materials for design of pavement thickness. It is the ratio of the load sustained by the specimen at 2.5 mm or 5 mm penetration to the load sustained by the standard aggregate at the corresponding penetration. It is expressed in percentage. Apparatus required. Mold, 15 cm inner diameter, 175 mm height, base plate thickness 10 mm, collar 15 mm height. Cylindrical plunger, 50 mm diameter, at least 100 mm long. Dial gauge, for measuring penetration values. Proving ring, for measuring load. Metal disc spacer, 148 mm diameter, 47.7 mm height. Annular metal weight and slotted weights, each of 2.5 kg, 147 mm diameter, central hole of diameter 53 mm. 20 mm sieve. About 5 kg of soil sample. Rammer, 4.89 kg. Procedure. 1. Preparation of remolded specimen. Prepare the remolded specimen at Proctor's maximum dry density or any other density at which CBR is required. Maintain the specimen at the field moisture as required. It can either be maintained at optimum water content or the field moisture. 2. Compaction. The remolded sample is compacted dynamically. It can either be compacted statistically by the help of compression machine or dynamically by using rammer. For dynamic compaction, sieve the soil sample, about 5 kg, through 20 mm is sieve. The material used should pass 20 mm is sieve, but it should be retained on 4.75 mm is sieve. Mix it thoroughly with the required water. Insert the spacer disc over the base. Place the filter paper on the top of the spacer disc. Clamp the mold along with the extension collar to the base plate. Pour the mixed soil in the mold such that it fills 1/5 of the mold. Give 56 blows with a rammer weighing 4.89 kg, dropping through 450 mm in 5 layers for heavy compaction. Light compaction can also be done with a rammer weighing 2.6 kg, dropping through 310 mm in 3 layers. The top layer of the compacted soil is scratched. Again, second layer is filled and process is repeated. After the 5th layer, remove the extension collar and trim off the excess soil by a straight edge. Remove the spacer disc. Turn the mold upside down. Place a filter paper on the perforated base plate and clamp the perforated base plate onto it. 3. Testing. Place the mold containing the specimen in the position on testing machine. Place the annular metal weight of 2.5 kg on the top surface of soil. Bring the penetration plunger in contact with the soil surface. Place the slotted weight of 2.5 kg on the top surface of soil such that the total surcharge weight equals 5 kg. Set the dial gauge reading to 0. Apply load at the rate of 1.25 mm per minute. Record the load at penetration of 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5 up to 12.5 mm. In dial gauge, we can see that one division equals 0.01 mm, so when the arrow in the dial gauge shows 50 division, it means that the penetration value is 50 times 0.01 equals half a millimeter. Now note the reading in the proving ring as 8 divisions. For this proving ring, the calibration factor is obtained from the equation, y equals 3.85167 x plus 0.99821 kg, where x represents the division in the proving ring. The calibration factor differs according to the proving ring used. So the reading in the proving ring is y equals 3.85167 times 8 plus 0.99821, that is 31.81157. Again, when the arrow in the dial gauge shows 100 divisions, that is, it completes one round, then it means that the penetration value is 100 times 0.01 equals 1 mm. Now note the reading in the proving ring as 15 divisions. So the reading and the proving ring is y equals 3.85167 times 15 plus 0.99821, that is 58.77326 kilograms. In this way, take the required readings. Collect the sample of about 20 to 50 grams, to determine water content. For soaked CBR, soak the sample with the surcharge weight in water tank for 4 days. 4. Computation of test results. Plot the graph of load penetration curve in which load is in y-axis and penetration is in x-axis. Sometimes the initial portion of curve is concave upwards due to the surface irregularities, error in reading, defect in equipment, etc. In such case, we need to apply correction. Draw tangent at the point of greatest slope. The point where the tangent meets the x-axis is the corrected zero reading of penetration, new origin. From the curve, determine the load value corresponding to penetration at 2.5 mm and 5 mm. Calculate the CBR value as CBR, percent equals load sustained by the specimen at 2.5 mm or 5 mm penetration slash the load sustained by the standard aggregate at the corresponding penetration. If CBR value at 5 mm is more than that for 2.5 mm, the test should be repeated. If the check gives the same result again, CBR for 5 mm penetration is adopted.